Okay, so this one, so this one, we relate back on the concept for sufficient statistic, and then we need to show this one is a complete sufficient statistic. And then the last part, you want to show that, or you want to find the unique minimum variance unbiased estimator. Okay. So normally the question, kalau tak ada show, verify lah. Show that means we already give you a hint that this one is your sufficient statistic. Find, that means you have to find lah, but you're not sure whether your value is correct or not. Okay, show then that means show. Kalau let's say if we design the question for show or prove that, so it's actually a bonus mark for you lah. Okay, because you only know the solution, so you need to derive until you get the solution. Okay. So the first part, you want to show that y equals to maximum ordered statistic Xn is a sufficient statistic for theta. So some of the question, it's not question lah, notation notation, we write, okay, you have X max. Okay, this one is also a notation for Xn or just Xn. Okay, ataupun if you have X bracket for ordered statistic, it's the same thing. X maximum, Xn, so that means you have maximum ordered statistic. So this one, ini distribution apa ni? So this is a uniform distribution, 1 over theta. Okay, now you check your range. Your range now is between 0 and theta. Okay, your X is depend on parameter theta. Okay, so you want to show that y equals to xn is a sufficient statistic for theta, and then you want to show that this is a complete sufficient statistic. Okay, first part, if we want to construct, we need to construct the joint PDF because we want to show that your xn is a maximum ordered statistic. Okay, since we already know that if we solve the MLE for uniform distribution, given that the range is between 0 and theta, so you have 0, x1, x2, up to xn. Okay, so if you solve the MLE, we cannot set equal to 0, so because the equation does not yield any solution. So the answer for this one, for MLE, is your Sn, Xn, maximum ordered statistic. So knowing that your MLE is your sufficient statistic, okay, so when you derive a joint PDF, we can write this one. So you have joint PDF, so we have 1 over theta to the power n. We use indicator. Ini indicator ya, bukan I, indicator. Indicator, so that's mean indicator for Xn, which is your maximum ordered statistic. So your Xn here is from 0 up to theta. Okay, the rest, which is x1, x2, and xn minus 1, so you will have 0 up to xn. Dia punya range dia, 0 up to xn. So indicator xi, so your product is I equals to 1 up to n minus 1. So that's mean you have x1, x2, up to xn minus 1. So that's why your range 0 up to xn, because before here you have xn minus 1. Okay, so this is your joint PDF. Okay, by factorization theorem. So by factorization theorem, so you split into 2. So the part that does not depend upon theta is just your indicator for xi. Yeah. So the part which is depend upon theta is 1 over theta to the power n. So you have indicator xn. Okay. So by factorization theorem, your Sn is a sufficient statistic for theta. Okay, your maximum ordered sufficient statistic. Okay, so that is for uniform distribution. So again, if you have your exponential distribution pun the same thing lah. You have to check the range. Tengok range dia macam mana. Okay, it can be either first ordered statistic or largest ordered statistic. Okay, second part. Second part, you want to show that this one is a complete sufficient statistic. Okay, you have sufficient statistic. Second part, a complete sufficient statistic. So when we mention about complete sufficient statistic, so that means we need to find what is the PDF, okay, PDF family of your y. Okay, your y now is your maximum ordered statistic. So that means you have to know what is your PDF for maximum ordered statistic. Okay, so we need to find the PDF for xn. Okay, remember back, if you have PDF for maximum ordered statistics, so relate on the topic of mathematical statistics, so you need to use the formula lah. Use the formula how we can show that or how we want to find the PDF for maximum order statistic. So again, we find the integration. So we have capital Fy. So you integrate 1 over theta dt from 0 up to y. So you have y over theta. This is your capital Fy. Your small fy is 1 over theta. This one is your capital Fy, your cumulative distribution function, your CDF. Okay, the PDF of n order statistics. So please check the formula. The formula in the list of formula. Okay, PDF for order statistic. So we substitute. Okay, substitute. So you have n y over theta to the power n minus 1, 1 over theta. So it gives you this value. N y n minus 1, so theta to the power n, theta minus 1 cancel out with this theta, so left you with theta to the power n. Okay, this is the PDF for n ordered statistic. So now you want to show that this one is a complete family. So using your expected value. Okay, yeah, yeah. Okay, this is your PDF for n ordered statistic. Yeah, ny n theta, ny n minus 1 over theta to the power n. So second part, you want to show that expected value of, let's say, uy is equals to 0. So that means you need to integrate your uy times your fy dy. Okay, range from 0 up to theta. Okay, because just now we have 0 less than x less than theta. So that means we have this one lah. Okay, katakan tadi your Sn. Okay, less than theta, so 0 less than y less than theta. So integrate uy fy dy. Okay, so to show that y is a complete family, so find the expected value of uy. Okay, you need to show the expected value of uy is equals to 0. How you want to make sure that your expected value of uy is equals to 0? So expected value of uy times your density function, ny n minus 1 over theta to the power n dy. Okay, range there 0 up to theta. Okay, so since our theta is greater than 0, this equation is equivalent to uy yn minus 1. Okay, in this case, the value which is does not depend on y here, ini value yang tak depend on theta, value which is does not depend on y, you have theta to the power n and also n. Okay, so that's mean same thing lah here. We have 0. So you have 0 n over theta to the power n uy yn minus 1 dy. Okay, this part ni does not depend on y. So you can bring to the left side, so it goes 0. So it left you with this one. Okay, so now the question is how you want to make sure that this one is equals to 0. So now we add another theory lah. Okay, theory ni from the books. How you can solve this equation is by taking the partial derivative with respect to theta, using the fundamental theorem of calculus. Okay, so this one, let's say, yeah. Okay, let's say if you integrate, konsep balik lah konsep 0y ft dt, konsep integration So if you solve this one, you will get fy lah normally. Okay, so that means if you differentiate capital Fy you will get back your small f. Okay, this one, ini biasanya capital F, CDF. Small f is your PDF. Okay, so integrate small f, you get your capital F. Differentiate back your capital F, you will get your small f, which is your PDF. Okay, so same concept So that's mean kita differentiate integration FTDT ni, we will get Fy. So we will use this one. Okay, concept fundamental theorem of calculus. But you can also refer this example to any reference textbook, or you can Google lah how to solve this one if you not sure how I solve this one. Okay. The next step. Okay. Since your okay, so now let's say we have FTDT, so you get Fy. That means you already substitute your y. So the same thing, you substitute, you have u theta, theta to the power n minus 1. Okay, so now since theta is greater than 0, so this theta ini is greater than 0. So the only way to make sure that your expected value is equals to 0 is by setting u theta is equals to 0, your coefficient. Okay, sebab this theta ni, theta n minus 1 ni, must be greater than 0. Dia punya condition, restriction dia. So since our theta is greater than 0, the only way to set equals to 0 is by setting the coefficient u theta is equals to 0 for all theta. Okay. So daripada sini, this one, kita gunakan fundamental theorem of calculus. Tak ada apa pun, just maksudnya if we integrate small f, you get capital F. So if you differentiate back your capital F, you will get your small f. Okay. So now you will differentiate with respect to d theta lah. Okay, d over d theta, 0 theta. Ataupun let's say, okay, if we rewrite back, so that means this one d theta, you will have 0 theta uy yn minus 1 dy. Macam itulah, dia kurang. Same thing. So that's mean we take the partial derivative with respect to theta using the fundamental theorem of calculus. So it will give back you u theta, theta n minus 1 using this concept. But since our theta is greater than 0, so you need to set that u theta is equals to 0. So you need to set the coefficient of u theta is equals to 0 for all theta. So by the definition, y is a complete and it is a sufficient statistic for theta. Okay, so by the definition, y is a complete and sufficient statistic for theta, or we can write y is a complete sufficient statistic for theta.